In this video, we'll discuss the Gaussian and Gauss-Jordan elimination. Now, these two methods are methods for solving a system of linear equations using an augmented matrix. Within that matrix, we're going to use three operations: replacement, interchanging, and scaling. And sometimes we'll use one or more of those operations throughout the solving of the problem. The difference is that when we do Gaussian elimination, we're putting this thing in row echelon form so that we have our numbers on the diagonal and zeros below on each column, so that our final row has exactly the solution for one of the variables. Then we can use that to substitute one row at a time to find the other missing variables. In contrast, the Gauss-Jordan elimination uses reduced row echelon form. This is where we'll have ones on all the diagonals and zeros in the other places, so that our right-hand column represents the solutions for each of the variables in the system of equations. Let's actually look at an example to help understand this. So say we have this system of equations, and what we're going to do is we're going to first put it into an augmented matrix. There are three variables, A, B, and C. Recognize that in our first equation, there is no C, so we need to put a 0 in our matrix for that value. So in the first row, that would be 2, negative 2, 0, and then another negative 2. Wherever there is just the variable listed, remember that as a coefficient of 1. Hence why we have our 1 on A and on C, and then a negative 1 on this A down here. Now, sometimes you'll see a vertical line put here to help represent the augmented matrix component. Other times you'll see it just written as one large matrix. So remember, we have three different methods we can use. We can replace a row, interchange a row, or scale a row. In this first one, we're going to turn this 1 into a 0 because we want to make this 1 and negative 1 become 0 and this negative 4 become a 0, so that our zeros are here and we have our diagonal then. So if I look at how can I make this 1 become a 0, I have multiple methods. What I'm going to do is I'm going to take the second row and subtract half of the first row, because 1 minus half of 2 gives me 0. 6 minus half of 2 will give me, in this case, since it's a negative 2, that's going to make it positive 7. This will stay 1, and then 28 minus half of negative 2 will give me 29. So there is my new second row. Now I'm going to work on this third row and make this negative 1 become a 0. So if I think about doing the same thing, I can add half of the first row to my third row, and then this will become a 0. And that is what I'm going to do here. So half of 2 plus negative 1 is 0. Half of negative 2 plus negative 4 is negative 5. This will stay 8. And then half of negative 2 plus negative 11 becomes negative 12. Now I need one more value so that I can get my row echelon form, which is, in this case, the negative 5 needs to be removed. So I'm going to use my replacement as well between the 7 and the negative 5. So sometimes I have to use fractions to make this work. So in this case, since they're negatives, I just need to multiply my second row by 5/7 and add it to my third row. And I know we're going to deal with fractions, but we have calculators that can help us with that. So when I do that, negative 5 plus 5/7 of 7 is positive 5, so that becomes 0. And then 8 plus 5/7 will give us 61/7. And then negative 12 plus 5/7 times 29 again will give us 61/7. Now here, we want to get our final value in this column to be a 1, so that it'll tell us exactly the value of C. So I'm going to say, well, what do I need to make this become a 1? I'm going to multiply it by its reciprocal. So I'm going to multiply by 7/61. And by doing that, I will maintain the 0, this will become 1, and this will become 1. This tells me now in Gaussian elimination that my C value is 1. Now I can take my value of 1 and substitute into my other equations, because this one is 0a plus 7b plus 1c equals 29. So I'm going to use that and say, let's substitute in the 1 for C, and then solve for b. When I do that, I get 7b plus 1 equals 29. So 7b is 28, which means b would have to be 4. So now I have two values, b and c. I can substitute them back into my very first equation, and I can substitute in the values I have. In this case, that's 2a minus 2 times positive 4. There is no c value, so then now equal negative 2. When I go to simplify, I'm going to get 2a is 6, so a would have to be 3. So my a value is 3, my b value is 4, my c value is 1. If I want to write this in matrix form, what I do is I write x equals 3, 4, 1. Now say I want to keep going with the Gauss-Jordan elimination. I pick up with that last matrix I started with, and I continue to put this into reduced row echelon form. So I'm going to continue working with my matrix. So again, I have replacement, interchanging, and scaling. First thing I'm going to do is I'm going to remove this 1 right here by subtracting row 3 from row 2. So when I do that, 7 minus 0 is still 7, but 1 minus 0 becomes 0, and 29 minus 1 becomes 28. Now I can scale my middle row, my second row. So I'm going to do 1/7. And that's nice because 28 divided by 7 is 4. So I have 2 of my variables determined already. Now I just need to simplify my top row. So if I take a half of row 1 and add row 2, well, half of 2 is 1. 1 plus 0 is 1. Half of negative 2 is negative 1 plus 1 is 0. 0 and 0 stay 0. And then negative 1 plus 4 would give me positive 3. And by doing that half at the same time, I end up in reduced row echelon form, which again shows me that A is 3, B is 4, and C is 1, which is exactly what I got when using the Gaussian elimination method as well.